You learned back in GCSE transformations of shapes. So, what are transformations of functions and what are we looking for? Here is a graph of y equals x squared minus 2x. And we are going to transform it. When I drag the slider, look what happens with the graph. That transformation is called a translation to the right, and now from the green to the left. So the green one is y equals x squared minus 2x, and now I translate it to the right, and I obtain the red function. So the question is, when we know the rule of the initial function, in my case the green function, how do I find the rule of g? The transformations that we are going to study are translations, and translations can be horizontal or vertical. We just look at the horizontal translation. Stretches, horizontal and vertical, and reflections on the x-axis and on the y-axis. So these are going to be the main transformations of functions that we are going to study. And the big question is, if I know the graph of f of x, the green one, and for example I translated 4 units to the right, looks like this point is mapped into this one, so 2 is mapped into 6, so 4 units, for example, to the right, what's going to be the rule of the new function without actually deriving it from the graph, but deriving it from the initial function? That's a question we are going to answer today. Okay, so let us look at the green graph, which is y, or f of x equals x squared minus 2x, and the new red graph. So because I have now two graphs, I'm going to call y old and x old the points on the old graph, the green graph. Look, for example, at the point to 0. So the point A, let's say, is the point of coordinates to 0. So x old is 2 and y old is 0 for this point, right, for A. Point A is mapped onto point B of coordinates 6 and 0. So point B will have the coordinates 6, 0, and it's a corresponding point of A. That's why I chose it, because we move A onto B. So the x new will be 6, is x coordinate of B, and y new is going to be the same 0. So that's for B, where A is mapped into B. If I take two other points, like for example, this point here is mapped, oh, that's not a good point because it's mapped into the one here, which is at the intersection, so maybe we don't see so well. So let's take then, I don't want to take it on the x-axis again. Let me take it here, doesn't matter, right? So I'm looking at this point. Let's put P and let us put Q. So P is the point of the green graph, has the coordinates -1, 3. Yeah, let's quickly check. If I put -1 square is 1. 1 minus 6, 1 minus, 1 plus 2, 2 times -1, 1 plus 2 is 3, correct? So x old is -1, y old on the old graph is 3. Point P is translated into point Q of coordinates 3, 3. So x new is 3, y new is 3, the same 3. So we see how, because we translated horizontally by 4 units, from the x old to the y x new we add 4 and y stay the same. So however you take a point on the green curve of coordinates x old, y old, it is going to map onto a point on the new curve with the coordinates x old plus 4 and y old stay the same. Therefore, x new will be x old plus 4 and y new is going to be the same as y old. So I'm almost ready to write the equation of the red graph, the new graph. So any point on the red graph will have the coordinates x nu, y nu. But this one comes from a corresponding point on the old graph, right? The corresponding point on the old graph, being on the green equation, has the equation y old is x old squared minus 2 times x old, because it's on this graph. Now I need to move to the red one, so I need the new coordinates. But we know that y old is the same as y new. So y old, instead of y old, I put y new. And from here, x old is x new minus 4. So x old is going to be x new minus 4 squared minus 2 brackets x new minus 4. So the graph of g of x, the red graph, will be x minus 4 squared minus 2 brackets x minus 4. And this is the equation of the graph. And see, it's the same, so your g of x is the same as f of x minus 4. And this minus 4 denotes a horizontal translation 4 units to the right. Now your task is, try it yourself. Start with f of x equals x squared minus 2x and translate it 3 units to the left. Following the same thinking, get the equation of g of x, which is a graph after translating. So please pause the movie, draw the graph yourself, do the whole thinking, and then come back. You should have found that g of x is x plus 3 squared minus 2 brackets x plus 3, or g of x equals f of x plus 3. And this will denote an horizontal translation 3 units to the right, to the left. In a summary, what we discover is that if f of x is the initial function, f of x plus a is a horizontal translation by minus a units. Meaning that if a is bigger than 0, then it's a translation to the left. If a is smaller than 0, then it's a horizontal translation to the right by a units. So in order to fully describe a translation, a horizontal translation, you need to say horizontal translation, and you can add a units to the left, a units to the right, or minus a units. Make sure the direction is clear. Another way to write it, if you remember the notation from GCSE, is by the unit minus a0, by the vector, by the vector minus a0. So horizontal translation by the vector minus a0, and then it's clear that that is minus a to the right and 0 vertically. We are going to look now at vertical translation. And you are going to follow all the thinking as before and get the conclusion yourself. So that's a vertical translation. I take the same graph and I translate it up. And now I translate it down from the green graph. So the position I'm going to stop at represents a vertical translation 4 units up, or translation by the vector 0, 4, meaning 0 units horizontally and 4 units vertically up. As you see, this point here has the coordinates 1, negative 1, and was mapped into the point 1, 3. Now thinking same as before as x old and y old, x new, y new, and you see that for the point x old, for that point x old is 1, y old is negative 1, and is mapped onto x new is 1, y new is 3, find the rule of the red function. Stop the movie and try it yourself. So you should find that if f of x is the initial function, then f of x plus a represents a vertical translation by the vector 0a, or a vertical translation a units. In fact, if I put a vector 0, I don't need to put the word vertical. It's not a mistake, but it's clear that it's vertical because it's the second component of the vector. We also saw that if a is bigger than 0, translation is up. If a is smaller than 0, the translation is down. If you want to, and you'll need to remember this, see the direction of translation for positive and negative a is kind of different from the horizontal translation. You need to look back and put them both in a table so that you remember them. To summarize the two translations, if I take the function f of x equals x squared, and that's a graph, if I write g of x equals f of x plus 3, this is the horizontal translation, 3 units to the left. So this is going to be the point minus 3, and that is going to be the graph. If I write h of x equals f of x plus 3 outside, that's a translation by 0, 3. So it's 3 units up, because see, the 3 is applied to the entire f, and the graph is going to be like this. So this one is f of x equals x squared plus 3, whereas the green one is g of x equals x plus 3 squared. In fact, we call this one h.